8.3, build a method. So finally, we're gonna try and create a general formula for these sort of problems. My says, they love this name. I see that name all the time in this textbook. My says, I know how to find the area of a sector, or the length of an arc for central angles like 180 degrees or 90 degrees, right? Like we said, 180 was just half, 90 was a quarter. So that was pretty quick. But I don't know how to do it for a central angle that makes up more complicated fractions of the circle. In this diagram, the sector's central angle measures theta degrees, so it's unknown, and the circle's radius is r units, also unknown. So this could work for any sector amount of area, and any central angle and any radius. Use the diagram to tell my how to find the area of a sector and the length of an arc for any angle and radius measure. So let's have one for area and one for length. Okay, so it's always helpful to look back at the previous activity when we're trying to build a formula. So if I'm looking at all my formulas for area, right, I notice they all have something in common. Right, we all have 360 in this denominator. The numerator for each one of these is the central angle referring to the sector. So in this case, I'm just going to write theta over 360. And then I can see that within each, whatever I was multiplying this fraction by was always just the area of the circle as a whole. So any area is always just going to be pi r squared. All right, so that sounds like a very intimidating problem. It's a very quick formula that we can write, and it works every single time. Length. Well, if we look at length, we did the exact same thing. We used the same fraction when we wanted to find that section of the circumference. So I'm doing the same thing here, theta over 360, and then I'm just going to multiply by what I would normally calculate to find the circumference, 2 times pi times radius. Right, you could say diameter times pi, but they asked for it to be in terms of r. So we need to use r here. We can't just make up a variable that they didn't ask us for. All right, so that was, I'm sure some of you probably already figured that out on your own from the last problem. All right, this image shows a circle with radius and central anchor measurements. Find the area of the shaded sector and the length of the arc defined by the sector. So using our formulas, go ahead and try that. Okay, so for the area, we just really plug in the two variables we have, right? 160 over 360 times pi times 5 squared. All right, since we're leaving things in terms of pi, what I like to do is, since this is all being multiplied, it's commutative, or I guess you could say associative. It's commutative and associative. We can mix around the order. So I can really also write this as 160 over 360 times 5 squared times pi. And the reason I'm putting pi at the end is because I want to leave it in terms of pi. I don't want to multiply with the pi. So what I'm going to do is I'm going to put into my calculator in parentheses 160 over 360, because we always put fractions in parentheses, times 5 squared. And we get, it's a rational number, but it's repeating. I know 0.1 repeating is 1 over 9, but let's just use our calculator, right? Why make ourselves have more work? Right, we get 100 over 9. So 100 over 9 times pi. You could also write 100 pi over 9. Whichever one you like more. They literally mean the same thing. Since we're talking about area, this is in inches squared. All right, now for length. Same thing. 160 over 360, 2 times pi times r. So here we've got 2 times pi times 5. This is really just 160 over 360 times 10 times pi. I'm just going to put that first part in my calculator. So this is a nice trick. I had a lot of students tell me they didn't know how to do this. If you press second I combined two words. If you press second and then you press enter, it uses this function called entry, which is nice because it just enters what you previously entered in. So, oops, I didn't. Okay, so you gotta press second enter, and then keep pressing second enter until you get to the line you want. So I didn't want to rewrite this fraction again because it's sort of a waste of time. So here, it gives me that line right over. I didn't have to rewrite it. So it's little things like that that can save you some time. Replace the 5 squared with a 10. And I pressed the wrong button. I pressed graph. Don't do that. Great. And I get another irrational number, so I'm going to convert that. Not irrational. I get a rational, non-terminating number. It goes on forever. So I'm going to convert it. Let's get my calculator. And we get 40 over 9 times pi. And that's in inches. All right. That's it for today. Thanks for tuning in.